Hey everybody, welcome back to the AL Departments. So we're in a new year, it's 2024, and I think the statute of limitations on saying Happy New Year have probably officially passed, maybe even like a month ago, but the statute of limitations for let's look at 2024 has not passed, I think. So I wanted one of the first videos on this channel to serve as kind of a look at what is going to be interesting in 2024 from an ALD perspective. I'd just like to kind of overview a few topics that I'm going to be watching in 2024 that I think would be good and interesting for you to watch, both from an industry and a research perspective. We've had a few really interesting developments happen in the commercial space in 2022 and 2023 that are informing some of these things. So these 5 spaces are semiconductors, specifically gallium nitride devices, optical coatings, green energy applications, area-selective deposition, and sustainability initiatives. I think these really encompass 5 big areas of work, both from commercial side and from research side, and ones that are topical and somewhat important, kind of touch our everyday lives, and are certainly going to influence the future. So let's get into them. So the first thing I wanted to talk about was the semiconductor space. Are not in the same semiconductor space that we were in the 2000s when ALD was first adopted. We're now in the so-called more and more than more era of semiconductors, things that are not necessarily driven only by scale, but things that are driven by performance and quality of film, stuff that ALD is really good at, but kind of has been put into this box of, well, if it's a small device and we want to make it smaller, then ALD is going to be really good. Like when hafnium oxide was introduced in the Intel process flow in the 2000s. But the one thing that is really interesting right now are these more than more devices, these things like power semiconductors, RF devices, micro LED, photonics. It's something that a lot of ALD companies are focusing on right now. People like Bennick, they have their Transform platform that is starting to take off a little bit. Of course, there was the groundbreaking acquisition of Picosun by Applied Materials in 2022. At this point, if you go on Applied Materials' website, go to their ALD tools, it is these Picosun tools that are advertised there. I think everybody might have been curious, well, what was AMAT actually interested in? Maybe some people already could have guessed that, but it's their morpher tools and their sprinter tools. So these ones that are for, wafer fabrication up to 300 millimeters, specifically of these specialty niche semiconductor markets. And the one that I think is really starting to take off are these gallium nitride devices. You see GaN in a ton of different device markets. So you have them in power semiconductors alongside silicon carbide and silicon. It's not the largest and probably will never be the largest of the 3, but nonetheless, it is taking off really well. There's GaN in radio frequency devices. There is GaN in micro LEDs. And a bunch of different ALD solutions are coming out for this because of the oxide layer on the gallium nitride. So this gallium oxide that's at the surface, riddled with defects, it's a really bad, really poor interface for the performance of these devices. But it's a perfect opportunity to do what ALD is now really emerging to do, and that's interface engineering. So getting rid of that bad gallium oxide and replacing it with some much better passivation layer, something like aluminum nitride, that both can serve as a barrier against oxygen for further oxidation, and maybe a seed layer for a gate dielectric or something like that. It may be a barrier for the gate dielectric in any case if it's alumina, for example. But Bennick had their first tech day hosted jointly with SEMI last year at SEMICON Europa, which I think was a really, really big step. It was actually part of the program. I think it was very validating for ALD to have this type of activity actually jointly sponsored by the organizers, somebody as big as SEMI, to have it onto the program. And as far as I could tell, it was very successful. And one of the things that they focused on here was the adoption of ALD for GaN power devices. And we're seeing more and more players kind of come onto the scene here. Lead Micro, well known for their tools for solar cell fabrication. It's something like 10,000 wafers per hour on the ALD tools from Lead Micro, which is completely insane. You can go on their website. They are starting to advertise some semiconductor cluster tools now, both thermal and plasma. And Forge Nano is now interested in the semiconductor space as well. They've been talking about their ALDX platform, which is for exponentially improving ALD, and they have a bit of a take on an old technology, kind of bringing it to scale. And they're focusing solely on single wafer thermal tools and some proprietary hardware, proprietary reactor design. They're getting like ultra fast wafer throughputs, things like 12 nanometer per minute deposition rates and 90% precursor efficiency. It's completely wild. So yeah, I think this is a really exciting time for ALD in the semiconductor space. It's a real mindset shift, I think, from what it used to be before. So I'm looking forward to seeing how all of the companies and the new research and tools that get integrated, where that all goes from here. The next one I want to talk about is optical coatings. This is an application that I feel like has really started to come onto the scene for ALD last year in a big way. I think people have kind of been working on it for a little while and kind of got its break last year when cell phone manufacturer Xiaomi quietly announced that they were using ALD on the lenses of their mobile phone cameras. Basically, they were adding ALD onto their lenses to make an anti-reflection coating, which is really interesting. It's usually done with physical vapor deposition, but the lenses that are in mobile phone cameras, something like that's inside here, they're really small, they are really highly curved, or they are spheric lenses, meaning they have some complex geometry. And unfortunately, PVD does not do a very good job of getting uniform coatings onto those. But it's a pretty much tailor-made application for ALD. You have a weird geometry, you want something uniform, put down ALD there. So it's pretty cool that some large manufacturer of cell phones is actually using ALD in their products now, and it's not in the chip; it's in another component of the phone. There are some rumors that Apple might be evaluating using ALD as an anti-reflection coating on their phones, and I think if Apple ends up investing in this and putting it into their process, then that domino will make all the rest of them fall. You won't see Samsung sleep on something like this if their main competitor is putting it in there. And it was really interesting. I worked on this a little bit when I was at Bennick, and it's pretty much the main reason people buy or choose their phone now is because of the quality of the camera. So the fact that ALD is now enabling even better, clearer photos by having good anti-reflection coatings that reduce the lens flare and these things, I think it's pretty neat. And we're seeing a few different companies really investing their time and resources into making optical coatings great for ALD, Bennick being one of them. They have this atom grass anti-reflection coating, which has very low reflectance, has a wide band range. It's very cool. They have made a nice video where a piece of glass basically disappears in front of your eyes. And of course, there is Japanese company Optorun, who is solely focused on optical coatings. That's kind of quietly working in the background. You don't really see a lot from them on like LinkedIn or stuff like this. They do present at some specific conferences, and I think they're doing a really great job with their batch tools and kind of focusing on optical coatings as their own deal. And I don't think that this ends here. You have things like the Apple Pro Vision, this ski goggle AR headset that's come out. And the more and more we see things like this that are using micro LEDs, for example, for their displays, or are using waveguides to bring the light and project it into the actual display. And these are places that ALD is going to be really well suited for doing anti-reflection coatings, barrier coatings, things like this. Passivating the micro LEDs, for example, can even make distributed Bragg reflectors with ALD for micro LEDs. So this isn't going anywhere anytime soon. I found another interesting thing here is the company Swiss Cluster is starting to come on the scene. This is another ALD equipment company in Switzerland, hence the name. But they have made, I think it's their SC1 tool, which is a combined ALD PVD machine, which I think is really interesting. Obviously, there's going to be some applications for optical coatings to use this. can really probably highly tune materials this way. Basically, they designed it so you don't have to have any vacuum break between the two. You just flip the reactor to the other side, it looks like. But I'm interested to see what they come up with here and the applications they start to enable. So yeah, I think optical coatings will be a really interesting field to follow with ALD in the next couple of years. Number 3. So the third thing I think that we're going to see a lot of activity around in 2024 with ALD are green energy applications. Again, this is not something that is necessarily new. I think people have been working in these spaces for quite a while and trying to find some solutions for ALD, but a few of them are picking up now. I'll talk about 3 specifically. And the first one being lithium-ion batteries. So using ALD for lithium-ion batteries has been going on for a while. The core thesis of it being that you can put a thin ALD coating on the active material of an electrode, like high nickel NMC cathode, or on a silicon anode, a graphitic anode, something like this. And it basically helps to stabilize the active material. It prevents any unwanted side reactions with electrolytes. It prevents things like lithium dendrite formation that would short out a cell. Creates a nice stable solid electrolyte interface. So you can get a lot of electrochemical benefits from this. You get longer lifetimes, sometimes up to 10x the lifetime of the battery. You get better cycling stability. You can have better discharge capacities, so on and so forth. And one thing that's very interesting for this field now is Forge Nano. Forge Nano is probably known as the company for ALD for batteries. They are the powder ALD company. They've been beating this drum on batteries and have very well connected themselves and implemented themselves into this industry. And for a company that has been trying to and putting ALD equipment into the field, they announced last year that they are starting their own battery manufacturing plant. So this is called Forge Battery. It's going to be in Morrisville, North Carolina. And I found it to be such an interesting move from an ALD company. We haven't seen something like this in quite a while, where we have an ALD company that's not only selling ALD equipment, but they're also selling a product. Now you have Forge Nano with Forge Battery come out and be like, hey, we really believe in ALD. We believe that the batteries you can make with ALD are fantastic. And if you're not going to make them, then we're going to make them and sell them, which I think is really bold. So we should really look forward to seeing how this battery factory progresses, seeing what Forge Nano comes up with their new formulations and how they progress in the battery industry in 2024. The second green energy application that is interesting right now is with fuel cells. Basically, these electrolyzers where the catalysts in it are something like iridium or platinum, and they're not used very efficiently, and you need a lot of these metals in order to actually do the catalyzed reactions inside the electrolyzer, inside the fuel cell. So you have a company now like Spark Nano, which is Polpoot in the Netherlands, and they are coming out with some tools where you can really precisely load platinum and iridium onto a catalyst structure such that you can better utilize the platinum and iridium, so that you are more precise on how much you're using, and just really, really drop the cost of making these electrolyzers and making these fuel cells. You know, it's worth saying that Spark Nano is a company that, like OptiRun with optical coatings, Spark Nano has solely focused on energy applications, being batteries, fuel cells, solar cells, etc. And speaking of solar cells, the third application that is coming on the scene now are these perovskite solar cells. Not going to say really too much about them other than the fact that we have a new type of solar cell that could potentially use ALD. Some of the one application I've seen kind of tossed around recently is using thin layers of tin oxide as a charge carrier transport layer. I don't know what's going to come of this. I know that there are companies evaluating this. I know there's a lot of research going on. I'd be interested to see if somebody like Lead Micro, who already does PERC solar cell manufacturing, is going to be on top of this, and whether they, throw their hat in the ring and this is something that, is going to blow up, or if it's not. But either way, I think it's an exciting thing to watch. In any case, we are at a precipice in our world where we need to invest in green energy applications anyway. So I don't see these ever going away, and I really only see people continuing to push hard to make sure that we get the best products that we possibly can out of this. And if ALD can help there, then ALD can help. Okay, number 4. So this is going to be more of a research topic than it is an industry topic, but nonetheless super hot for ALD, and that is area-selective deposition. This is really blowing up alongside things like atomic layer etching. I mean, basically, both of these have now garnered their own events, with ALE being part of the ALD event every year, but the area-selective deposition has its own event now as well, the ASD, which is now on its 8th year. This year it's going to be in Montreal, Canada. It's being run by Sean Barry from Carleton University. And basically this is motivated by semiconductor manufacturing. Basically, as we are getting smaller and smaller and smaller with our devices, and somehow we continue to do it because as humans, we are pretty amazing at this stuff. You get to a point where this top-down patterning that we do, where we take kind of block of material and you do lithography, right? You make a mask and then you pattern with lithography and then you create your kind of device structure. That way, this top-down approach gets a little bit hairy when we get down to such tiny dimensions, when we're down on less than 10 nanometers in terms of the actual feature size, such that little errors and line edges and things like this that aren't lining up really are going to ruin the yield of chip manufacturers and are really going to make it much harder to fabricate these devices. So instead of this top-down approach, we want to flip that so that we can do bottom-up, meaning that instead of starting with a block and then patterning it and etching it and depositing that way with a kind of stencil, we just from the beginning start with a blank slate and we just build up material exactly where we want to build up material. And this is where area-selective deposition comes in. All of these strategies that have been coming out from the research community are towards a way of how do we put material down in one place and not put material down in another place. And there's a few strategies on how to do this. I won't go into detail on this. Maybe in another video I can do a quick overview of how area-selective deposition works. But one of the main ones is using inhibitors, for example. So you put down small molecule inhibitors that selectively absorb on one surface and then they block a particular deposition, either from steric hindrance or it just makes the surface inert or something like this. But then you only grow on the surface that doesn't have inhibitors and you don't grow on the one that does. In any case, there is so much work and so much research coming out at a rapid pace from the ALD community on this stuff. There are a ton of really prolific groups working on this. You have Audrey Mackes and Erwin Kessels and Eindhoven working on this. Stacy Bent is doing area-selective deposition at Stanford. The Helsinki group is doing area-selective deposition. Hanbo Ram Lee and Incheon is doing area-selective deposition. There is a ton. And if you go to the ASD website, you can see a bunch of support from industry companies as well. There's people from IMEC that are going to be speaking at this conference, Tokyo Electron, people from Intel, people from Lam, people from AMATs. I mean, it's really, really huge and crazy how this has blown up in the past few years. But even from the research side, there are companies from the specialty ALD markets side as well that are looking into this. I mentioned that Audrey Mackes and Erwin Kessels and Eindhoven are doing this, and you might know the relationship that Eindhoven has with Oxford Instruments. They work with them quite a lot. They do tons of research, tons of case studies. I mean, Harm Knopes works back and forth with the university and with Oxford Instruments. And they even have a case study on area-selective deposition using one of their Flexol reactors, which I think is pretty cool to see the area-selective stuff actually being done in an industry tool. You just have some of the world's best minds that are working on this problem right now, and it's super topical, super relevant. There's a ton to work to understand. So if you are interested in getting into ALD research, This might be a topic that you might want to start thinking about. It's not going anywhere. There's a lot of problems to solve and a lot of opportunities. So certainly looking forward to seeing what comes out of this in 2024. The final topic I think will be nice to watch in 2024 goes along with the green energy applications. And I think these are all of the sustainability initiatives that are coming out of both like semiconductor and the ALD community. They're, kind of one and the same in this case. Same with the green energy applications. Like we are at a precipice here where we really need to take a good hard look at our own industries and see, well, where can we help and where can we make things better? Where can we lower emissions? Where can we decarbonize? And how are we going to do that? It's not an easy question at all, but thankfully there are a ton of initiatives that are happening that are working directly towards solving these problems. The first one that comes to mind is here in Finland. It's called Chip Zero. And this was first started by Applied Materials PicoSun. It was announced last year. And it is essentially a consortium of companies in Finland that make up the semiconductor ecosystem in this country that have the goal of working towards decarbonization of their chip manufacturing. The ultimate goal that they state on their website is that they are going to reduce the emissions of the chip manufacturing process in Finland by 50% and increase the handprint. If you don't know this, the carbon handprint is the positive impact that your organization or process has by the double digits. So the goal is that by 2030, just 6 years from now, the Finnish semiconductor ecosystem will have net carbon emissions, net zero, which I think is really an incredible initiative. All of the companies that are working towards this, Applied Materials, Comtech, Chipmetrics, Canatu, Okmetic, there's so many that I can name that are part of this. It's such a great initiative. I'm really happy to see the place where ALD was born working towards this. Another fantastic initiative I've seen come out is from IMEC. This is the Sustainable Semiconductor Technologies and Systems, which is SSTS. This is basically to help people who are creating integrated circuits meet their sustainability goals. And of course, if you don't know IMEC, IMEC is an organization in Belgium that is pretty much the biggest hub of semiconductor research and technology transfer in the world. I mean, they pretty much work with everybody. So they're in the perfect place to be helping companies reach their sustainability targets, for helping companies innovate in this space. As part of the SSTS program, they've launched what's called the IMEC Net Zero Virtual Fab, which is super cool. Basically, it is a place where a company can put in all of their process flows, their equipment, all the parameters with how their fab works, and this will essentially calculate all of the metrics around their emissions. It'll look at energy use, carbon emissions, greenhouse gas emissions, look at mineral use, all of these things, and then spit out basically a report on this about how they're being used. And IMEC is encouraging companies to use this, and then taking that data and turning it into real informed projects and figuring out, okay, now how do we address high energy use? How do we address high greenhouse gas emissions? How do we address all of the water usage, and so on and so forth? Again, IMEC is in a perfect position for using this, and they're encouraging everybody they can to use it. Companies like ASML are on board, Tokyo Electron, TSMC. I mean, all the big guys are part of this now. I'm really, really excited to see somebody. I'm really excited and really humbled to see somebody taking the steps to take the reins of this and really turn it into something tangible. It's completely necessary. We need it so badly. So my hat's off to IMEC. And I'll be interested really to see what kind of data about ALD will come out of this, as of course ALD is part of these semiconductor companies' processes flows. And then of course there is, from the actual ALD side, a lot of research now is starting to come out about life cycle assessments and the environmental impact of ALD. One group in particular that I see publishing on this a lot is at CNRS Grenoble. They've put out a couple of papers recently that I've really liked, authored by Matteo Weber. And they're looking at basically, okay, for a particular ALD process, for an ALD system, where is most of the emissions coming from? Where does most of the energy consumption come from? Where are the places that we can improve on this? One of their latest papers talks a lot about using spatial ALD because it's so quick. I'd be interested to see like a life cycle assessment for forged nano tools, particularly these ones that have very high precursor utilization and are super fast single wafer tools. See if that is like another avenue to go down in order to decrease the emissions of ALD. In any case, all of these findings that are coming out of these groups, like at Grenoble, this is exactly the data that we should be using to inform how we create new reactors. How do we develop new processes in the future? So again, hats off to them as well for putting in the groundwork here and doing some really, really important research that will certainly help inform development of ALD in the future. I can't really stress enough how absolutely critical all of these activities are. The Chip Zero, the SSTS at IMEC, these life cycle assessment, environmental impact work coming through. The guys like Henrik Peterson and Sean Barry, Jonas Sundqvist, who wrote the paper on green CVD, like all of this is so completely crucial to us moving forward as a species and us as a field and community. It's really our responsibility to make sure that we are acting responsible in how we're developing technologies and future-proofing them for the future that we are going to have to take over. So again, I really thank everybody who has been working on these technologies and working on these initiatives, and I only stand to see more good things coming from them, and I think it's a really important one to stay on top of for 2024. So there you have it. Those are the 5 things in ALD that I think you should watch in 2024. I know I will certainly be watching them, and there are so many cool things that are happening in this field. I chose 5 that are really hot in industry, really hot in research right now. But of course, there's stuff like atomic layer etching that I could go into excruciating detail about how that has had its meteoric rise since Steve George's group started doing it in 2016. There's all the new vapor phase infiltration, sequential infiltration synthesis. There's molecular layer deposition work that's going on. I don't want you to think that there aren't a million other awesome topics that we could discuss, and certainly we will discuss on this channel. But yeah, I think that semiconductors, specifically GaN technologies, optical coatings, area-selective deposition, green energy applications, and the sustainability initiatives, these are a group of 5 really huge things that we are going to see a lot of visibility on this year, I anticipate. So hope you enjoyed this video. If you did, please consider subscribing to the channel. Really appreciate the support. And yeah, tell me in the comments what you're going to be watching in 2024, what topic you're super excited to see a bunch of awesome work come from. I'm excited to see it all from you. So thanks. We'll see you in the next video.